Why vulnerability management? Since it is both a security best practice and frequently a compliance requirement, just about everyone needs to manage vulnerabilities in their network. In our discussions, we found that many people turn to vulnerability scanning to help address this problem, but struggle to manage the vulnerabilities they find due to time, personnel, or budget constraints. Truly managing vulnerabilities allows you to understand the vulnerabilities in your network and make resource-conscious and risk-based decisions about how to address them. We set out to build this solution. When we discussed vulnerability management with our customer base and reviewed regulations across several industries, we identified a few key areas that needed to be addressed. First, vulnerability management is more than scanning. Just conducting a scan and collecting results is not truly managing the vulnerabilities. The second question people asked, how do I address all these findings to both feel confident about our security and prove to boards, bosses, and regulators that I'm meaningfully addressing the vulnerabilities? How can I do this while juggling my other duties and without straining resources on my team? The numbers always look bad, and it's hard to explain that things are actually being managed. Thirdly, people said that they needed sufficient information to determine how to remediate vulnerabilities so that they or their team members can easily determine how to fix them. And lastly, people needed a simple, concise report to prove that they are thoughtfully addressing security and doing it in a resource-conscious way. We took this information and built TraceInsight to help our users address these four main areas and allow them to meaningfully implement vulnerability management with low overhead. Before starting with TraceInsight, you'll download a virtual machine image of our scanning appliance and install it on your network. Since all scanning is authenticated, you'll need to make sure that the scanner can access all machines to be scanned via WinRM and group policy or SSH credentials. Our support team will provide documentation and assist you or your MSP with getting this configured. Additionally, you'll install an ARP scanner. Put on each subnet, this will scan for any hosts on your network. ARP is a low-level network protocol that allows us to find all devices, including any rogue devices, to ensure that we identify any machine that is sitting on your network. This is all a one-time setup. Once completed, all functions are done through the web interface. Here we will simulate an ARP scanner running and detecting results for the first time. Our scanner has identified 5 machines and populated the IP and MAC address for each device found. Now that we have identified machines, we'll create a scan. We'll call it our weekly scan and tell it to scan the master host group. This is going to scan all hosts found on your network by the ARP scanner and will update as machines are added and removed from your network. We'll set this to run at 5 a.m. weekly. Every Saturday morning. From this point on, you typically won't need to make any adjustments to this scan or your scanners. The ARP tool will continually identify hosts on your network, and this scan will occur for all known devices every week. Now let's simulate our first scan. Our scanning solution uses community-maintained signatures that cover the most common operating systems and devices. All findings are sourced back to a common vulnerability and exposure ID, or CVE ID, and each has an associated common vulnerability scoring system, or CVSS score. On the dashboard, we see that we have a recently completed scan. Let's click into it to see what we found. We see that it's attempted to scan all 5 hosts, and we have a quick overall view of what was found. Looking down the host list, we see that some have results and some have errors. Looking at this error first, we see that this machine is showing that the administrative ports were not opened. This means that we need to either enable WinRM or SSH on this device in order to scan. We'll make a note of this, and we'll want to make sure that gets fixed so we get results in our next scan. Let's move on to our important devices and see if we have anything critical to address. We'll jump over to the Manage Results area so we can assign and remediate as we go. All views for managing results are in table format and have filters to allow you to search through the data in a number of ways. When performing vulnerability management, We want to start with critical systems. So let's run a filter on our production database box to see how it did. After we apply the filter, we can expand to see an overall view of the vulnerabilities found. Since this is a demo, we've drastically reduced the number of vulnerabilities. It looks like there are 4 vulnerabilities that we failed. Let's look at all the failures by clicking there. Note that this is merely just applying a filter to our data set to show only the failed vulnerabilities on this host. This table shows us all of our failures with decreasing severity by CVSS score. For each vulnerability, we can expand to show additional details. Most importantly, we have external links and reference data to help us understand the discovery. A very useful feature we found is that we provide links not only to the original CVE, but there are also almost always vendor-specific links or reference numbers that help you to remediate for your exact system. The source CVE information is regularly updated by the security community. Most vendor-specific references will include remediation instructions. In this case, we're told to upgrade our bash software by running yum update bash. Another member of the team is responsible for managing that software, so we're going to assign this to another user to upgrade. Now let's move on to another critical machine, our production web application server. In this case, we want to address all vulnerabilities and assign them in bulk to the person who is responsible for this device. There are also occasions where vulnerabilities are found, but we don't need to immediately address them. In this case, instead of searching and filtering based on the host or node, we want to search by vulnerabilities. The host view shows all hosts with the associated vulnerabilities for each. The vulnerability view shows us all vulnerabilities with the associated hosts. Let's set a filter for failed unresolved vulnerabilities of CVSS score lower than an 8 that affects 2 or more hosts. Here's one for Java. However, we have a specific application that requires this exact version of Java. There's an upgrade coming to that piece of software, but for right now we have to maintain this current version. In this case, we'll mark this as acceptable and provide some information as to why. For now, we'll say that we're done. We need to fix that error we found earlier and make sure our team follows up on their remediation tasks and wait for next week's scan. All right, the next scan has occurred. Looking at this one, we see that the errors have been fixed and we have some new vulnerabilities to address. We can go through the same process, searching by vulnerabilities, hosts, and combinations to identify the most important things to address. For now, we'll jump into our report to show how the trending looks. Typically, this is going to have much more data across a longer time period, but our demo should get a rough idea of how this works. The first thing we see is the pass-fail graph. This is showing that our second scan actually scanned for more things because we fixed the host in error, but we failed slightly fewer than we did the first time. A logical question is, okay, so what did we fail, and is it bad? The second graph is showing failures and errors by severity. This includes any vulnerabilities that got in error state because we don't know if you are vulnerable or not. This graph shows that our overall failure rate has dropped, and importantly, we've reduced the number of vulnerabilities identified as high based on CVSS score. The next logical question is, what are we doing about these failures? This brings us to our third graph. Here we outline what we are doing to address these vulnerabilities. Our graph shows a few things. We see our acceptable vulnerabilities have stayed the same, as that status is carried over from the first scan. We also see that some of the assigned vulnerabilities from scan number 1 have been closed, meaning that the software was patched and the vulnerability is now resolved. Finally, we see that we're working our way down to get as many vulnerabilities out of the unresolved state as possible. Lastly, we see a graph showing the number of hosts we've identified and attempted to scan. In this case, it's been 5 consistently. However, this graph is helpful to explain when there are large changes in the vulnerability counts. Sometimes machines are added or removed from networks, causing large shifts. As you continue to scan and address findings, this report shows that you are truly managing your vulnerabilities and makes it easy to show that your team is thoughtfully addressing the vulnerabilities as an ongoing process. To begin managing network vulnerabilities the right way, click on the link on the screen.